In this video, we want to prove the lines again to be parallel, or line K parallel to line N, given that angle 1 and angle 2 are supplementary. Um, what we want to do here is use the given information, which they give a vocabulary word here that's supplementary. So what that tells me is that measure of angle 1 plus measure of angle 2 is equal to 180. That's going to be the definition of supplementary angles. Remember, the only time we use this definition is when the English word supplementary is given. Okay? I'm looking at my picture and I want to determine the two things add to 180. And my picture is probably going to tell me that it's the angle addition postulate. So that's all I can get from my given. Measure of angle 1 plus measure of angle 2 is 180. If I look at my picture, angle 2 and angle 3, if I look at those, that's kind of what I was saying. They form this straight line here. Okay. And when they form a straight line, we called them in class a linear pair before, but we can say that measure of angle 2 plus the measure of angle 3 is equal to 180. Now that is not the definition of supplementary angle, because I had to look at my picture to get angle 2 congruent to angle 3. Well, not congruent, but angle 2 plus angle 3 equal 180 degrees. That reason is the angle addition postulate, which if we look in our textbook, the second part of the angle addition postulate says if two angles form a straight angle or a straight line, then their sum is 180 degrees. Okay, so visually we're seeing this straight line. We know that these two things come to 180. Okay. Step 4, we've seen this before in class. We've got a pattern here. We have two quantities, their sum equal 180, and two other quantities, their sums equal 180. What we always want to do then is set this part here, measure of angle 1 plus the measure of angle 2, set that equal to that part, measure of angle 2 plus the measure of angle 3. Two possible reasons for that. Transitive property is the one I like the best, or you can call it substitution. It'd be transitive because if this statement here, we had a generic statement A, this would be a generic statement B. Likewise, this is the same, that'd be B, and this would be a new statement C. And the transitive property says if A is equal to B, but B is equal to C, then A is equal to C. So that's why we can set these two things equal to one another. Step 5, okay, the pattern continues. Whenever I have a statement like this, and I've got two quantities on the left-hand side, two quantities on the right-hand side of the equal sign, I want to try to see if I can remove something from both sides, and we recognize that symbol-wise, measure of angle 2 is on the left and measure of angle 2 is on the right. So I'm going to state that what I'm about to remove from both sides is in fact the same thing, and that's just the reflexive property. And then you can actually remove these, and when I remove them, I'd be left with measure of angle 1 equal to measure of angle 3, and removing from both sides is the subtraction property of equality. And once I know that their measurements are equal, I now know that the shapes are congruent. The definition of congruency always allows you to go from equality to congruency. Now what we have shown is that angle 1 and angle 3 are congruent. Okay? Well, if angle 1 and angle 3 are congruent, those are alternate interior angles. Okay? So if alternate interior angles are congruent, then the lines have to be parallel. We have a theorem in class that said two lines are parallel if they are cut by a transversal in a manner in which alternate interior angles are congruent. So, I'll write that out. Write it this way. If two lines are cut so that alternate interior angles are congruent. Then the lines are oh, then the lines are cut.